Ashutosh Natraj researches drones at the University of Oxford. He's brought his drone into the studio. Ashu, nice to see you.
Nice to meet you too here.
Wow. Just describe what's on the desk in front of you there.
So this is a very small quadcopter, meaning that you can see that there are 4 rotors on this one, and it's got a couple of cameras to ensure that you can actually go and see few things, and it's got a sensor on board which is for sonar sensor, which helps you to maintain the altitude. And this one is an off-shelf Parrot drone, which is from the company Parrot, which is called an AR drone, which you can buy it for 270 or 280 quid.
So that's under £300.
Under £300.
You've got a very impressive toy like that.
Yes, indeed. But the only thing is that I start to work on the software part to ensure that it's quite safe enough to fly rather than anyone else trying to fly using their phone or iPad.
Right. Okay, so let's just, before we set it off, because I know you're going to fly it around the studio, and what we'll do, we'll do some filming with this, so you'll be able to see stuff on our Facebook page later. So you do the software to keep it safe and to keep it in the air, and we were hearing about some of the rules there. So what do you have to bear in mind actually when you're programming that then?
Right, so a few things you need to ensure that, because as just now we heard that, to ensure that in the build-up area you need to be at least 150 meters or 100 meters away from the public area. And also is that when we are designing this, we ensure that the altitude never crosses 100 meters. So we give a restriction because that's the airspace. We do not want anyone accidentally to enter that area. So we keep this algorithm saying that, ever if you cross 95, it should give an alarm and automatically reduce the altitude to bring it down. And also if you are going beyond another 100 meters, because with your line of eyesight, because that's maximum range you can actually fly. Sure. So ensuring that when you're crossing that limit, you should be given a warning, and then again the robot should automatically trigger an algorithm saying that turn back, go back closer to your original pilot.
Okay, right. Well, we understand the science. Let's see it work. Can you just get it up in the air? And
yes. No.
Yeah. Right. So Ashu it's got all its day glow LEDs on the end of the sort of its arms. It's got its rotors on the 4 corners. It's got like a go faster orange stripe down it as well. Actually, it looks an excellent little toy. How quickly can you get it up in the air?
So it's almost ready now.
Right. So it sounds like someone's starting to hoover up.
So you can see that it's flying and.
Right. So just right. I'm in a studio which is probably, I don't know, about 6 meters by 6 meters, and it goes up to sort of normal ceiling heights. And that's brilliant. That is very, very impressive. Look at the control of that. It's flying at about sort of 4 foot at the moment. So on your screen in front of you there that you're controlling this, what are you doing exactly?
I'm just going to let it down now for the moment. So I'm going to let it down now for the moment.
You stopped concentrating there for a minute and it hit the wall.
So when you say this one currently, it's quite an interesting piece of work, because you can see on the screen here, it gives the trajectory of the entire flight path or what it has done. So right. I can actually have a control saying that where it has been flying over the trajectory, and also I can see the live relay from the cameras of the drone. So meaning that if I would like to do a mapping for search and rescue operation, I would really need this one. So when I see the features from the environment, I would build up a map. When I build up the map, it happens to make sure that we can ensure that the new map is built up over the existing one, so the fire and rescue team can actually enter quickly and identify a possible human being or an animal to rescue immediately out. And the trajectory path ensures that we know how it has trajected, like traversed the path.
You followed that route,
yes,
so you know
followed that route and
whether there or not.
Yeah.
The sort of imagination behind this, I mean, literally anything. I was speaking to somebody else doing the mid-morning show a few weeks back who's trying to get this as a delivery service.
Indeed, yes.
To use it to, I think they were trialling it in China at the time to deliver tea bags. I think it was the Chinese equivalent of Amazon were doing this.
That's correct. So the thing is, people have been trying this, but currently there is a big hindrance in this entire technology is that obstacle avoidance, because right now everyone uses to do piloting. Piloting is still not that safe enough because there is a room for the human error involved. So currently we actually at Oxford developed an algorithm for obstacle detection and avoidance, which works quite impressive. I can actually show you the video as well at some point of time and share it on the Facebook of Oxford BBC Radio.
Well, we're going to let you do some flying. We'll get it filmed and we'll get it up on Facebook, but you haven't damaged it. You're flying it into the studio.
No, I think it's not. It's just when it's beyond that limit, I just said, like, just go and land.
Yeah.
But then it just was quite a small tide, so I just landed.
Yeah. Actually, thankfully, I'm not on your aeroplane that you're flying. That's very impressive, though. Great bit of work. Ashu, thanks for coming in. We'll can't wait to see the film, actually. We'll get that up on Facebook ASAP. Ashutosh Natraj, who researches drones at the University of Oxford.
With exclusive access to Oxfordshire's travel cameras.
This is BBC Radio Oxford Travel.
Drone traffic cameras. That could be the future. Here's Sarah.
I'd like that. Temporary traffic lights in Oxford city centre still